Okay, so we are starting logarithms and exponents. So exponents you guys should be familiar with from like grade 9. Logarithms are a new thing. All of this fits your snap book, so for every day that we do, here's like the lesson and then the questions that you guys can be practicing. So we'll just get right to it. So today we're going to talk about what a logarithm is, because as I said, that's a new thing for us. So far we've seen linear functions, quadratic functions, and rational functions. But what happens if the variable is now an exponent? So like y equals 2 to the x, something like that. When the variable is an exponent, the function is called exponential. So when the variable is in the exponent, we have that exponential function. The inverse of an exponential function is what we call a logarithmic function. So these guys are kind of like similar but opposite. These functions are used to model stuff like pH, bacterial growth, and interest accumulated on a loan or investment. So especially this one, like this is a really real application. Like you guys will have to look at this at some point in your life. If you're buying a house, if you're saving up money, if you're looking at a mortgage, those sorts of things, these are really important applications. So to begin our study of the functions, we need to understand what a logarithm is. So an exponential function looks like y equals a to the x. So a is the base of the power, and that's going to be generally a number, and then x represents the exponent. So that's what's changing. That's what our variable is. A logarithm is the inverse of the exponent. So in other words, if we wanted to solve for what x is, if we want to isolate for that, we would express the function as a logarithm. So a log is kind of like, so if we have like 3x equals 12, we would divide both sides by 3, right? Undo the thing that is happening to the x to get it by itself. To get the x by itself with the exponent is a little bit more complicated than something like this. So that's why a log exists. So it is to isolate for the x, the exponent, in an exponential function. So we have log, which means logarithm, and then whatever the base is, so see how a here, the base is the base on the logarithm, and then we are logging whatever the y was, okay? So this is worth, like, knowing what goes where is worth memorizing, because I don't believe that that's on your formula sheet. So you need to know if you want to convert back and forth, you need to know what would go where, okay? So when we use a logarithm to solve for a variable, we're asking the following question. What value of x must be applied to base a? So we're looking at this little base. What value of x as an exponent must be applied to that base to produce y? So if we look at it as the exponential form again, we're talking about what exponent for the base would give us the number that we want. We're asking the same question in the form of a log. So what value of x must be applied to base a to produce y? So that's like why it's so closely tied to an exponent, okay? So when we're looking at log base 7 of 49, we're asking what value of x, so if this is equal to x, creates 7 to the x equals 49, right? What value of x must be applied to the base 7, here's my base, to give me whatever I call it logging. That is not the actual professional term, but I think it makes the most sense. So whatever number we're logging, so what exponent would we have to do there? 7 squared, we know, is 49. So this whole log would be equal to 2. Okay, if we were asking, this is like asking what value of x, right? So if this is equal to x again, makes 6 to the x equals 1 true, right? So what exponent do we need to raise the 6 to give us a 1 that we've been logging? And if you remember all the way back to like grade 9, anything to a 0 exponent is going to give you a 1. So the only thing that can make that true is 0. So log base 6 of 1 would be 0. This one we're saying, so if this is equal to x again, so what value of x means, I've used a different word every time, creates, makes, means, whatever, all the same, means that means that 2 to the x is equal to square root 8. And so this one's a little bit trickier. So we're gonna have to, we want 2 to something to equal to the square root of 8. So there's a couple extra things that we need to remember here. One of them is that an exponent to the 1/2 is equal to the square root. So you guys would have learned that in like grade 10. So that's one thing that we need to remember. We also need to remember from last year how to manipulate stuff under a radical, right? So I could rewrite, so if we want this whole thing as an exponent, right? And we want to figure out what exponent needs to be there to get this, I'm going to rewrite this as 8, instead of 8, 2 to the power of 3, because 8 is the same thing as 2 times 2 times 2. Okay, so 2 cubed is the same thing as 8. Now I can say, okay, if I needed 2 to be cubed, and then it needs to be square rooted, my x has to be the 3 from the cube times the 1/2 that we know that that square root means. And so my x is going to be equal to 3/2 in this case. Okay. So that one is trickier, but we have to come back to stuff that we learned in previous math courses. This one we've got log, and there's no little base here, okay? So there's a note on the next page, we'll cover this again, but anytime there's not a base, what it means is that base is 10. So we call that a common log. It's the most common logarithm. And so if there's no base, just like if you guys remember, like if we're doing square roots, if we're talking about a square root, we don't write the little 2 index, but if we're writing a cube root, we do have to write the 3, because the square root is the most common root, right? So when we're using the most common one, we don't actually put the index there, but if we're doing any other one, we put that index there. Okay, so same with logs. If we're doing the most common one, we don't have to put the base, but if it helps you to think through, okay, what is this asking me, like what is the value of this log? If it helps you to put that base, to write that base in, that is perfectly fine. So we're saying what value of x makes, so it's going to be 10 to the x, the base to the x, equal to 0.001. Okay, so this one again is kind of tricky. So last year you guys would have learned about negative exponents, or maybe in grade 10. But so like something like 10 to the -1 means 1/10. 10 to the -2 means 1/100th, because it's going to be 10, or so this is 1 over 10 to the +2. So 100, or 10 squared is 100. 10 to the -3 is going to be 1 over 10 cubed, which would be 1 over 1,000. So remember, when you've got a negative exponent, you're reciprocaling and then putting the positive version of that exponent there. So 1/1000th, if we think about decimal spots, these are tenths, hundredths, and then thousandths. So this is 1/1000th, which is this guy. So based on this pattern, we can say that x would have to equal -3 for this to be true. Okay. Now you guys can do these in your calculators, but my calculator looks a little bit different. So it's a little bit tricky for me to show you, so I'm going to show you in person instead of in the video. But you can get type all of these into your calculator and just get your calculator to show you what it's equal to. But I wanted to talk about what these actually mean, some of the strategies behind it, just so you have a better understanding of what your calculator is doing when you punch these things in. Okay, so yeah, since my calculator can't really show you, I don't want to show you in the video, but I will show you in class. So for more practice, we're going to write the following logarithms in exponential form. Okay, so if we have log base 6 of 216 is equal to 3, what that's saying is 6 to the exponent of 3 is equal to 216. So the base stays the base, and then these guys kind of trade spots. Okay, so it's worth memorizing or understanding. I guess understanding would be the better thing, but memorizing if you don't really if you're not 100% grasped on it, it's worth memorizing what goes where. Okay, this one, our base always is going to stay our base. The thing that the log is equal to is our exponent, and then whatever was being logged is alone on the other side of the equation now. So this one is 2 to the 4a equals b minus 10. So we're just practicing writing what goes where. What I tend to do is I write myself a little guide on the top of every quiz, assignment, whatever. So I know that 2 cubed is equal to 8. And I also know that log base 2 of 8, so we're saying what exponent do we have to raise the 2 to get to 8 is 3. So I would just write a nice easy exponent that I know, and it should all be unique numbers so that I know, okay, the 8 goes there, the 2 stays the base, the 3 goes there. And I can kind of use that as a pattern and apply it to different situations if they look a little bit different. So here again, base stays base. What it's equal to is, so we're going the other way. So base stays base. What we're logging is what it's equal to. And then what the log is equal to is the exponent. Okay, so yeah, that can kind of be a guide. Our next example, so write the following exponents in, or I guess these should be logs in exponential form, solve if applicable. Okay, so this is saying 5, right, base 5 to the negative 3 exponent is equal to x. And this is something that we can find a number for. Okay, so we can solve this guy. So we can go 5 to the negative 3 is the same as 1 over 5 to the positive 3. And then 5 cubed, we can go, that's 125. Don't know why I wrote the 2 first. So x would be equal to 125. So to check that, we could punch in log base 5 of 125 into our calculator. And my calculator is just too old for me to be able to show you that. This one, we've got log base 2 of 32 is equal to x. So this one on our calculator, we could just punch this in right away to solve for x. We can also think about what x could be just using our math skills and converting to exponential form. So 2 to the x would have to be equal to 32 is what this thing is saying. So we can think through, okay, 2 to the 1 is 2, 2 to the squared is 4, 2 cubed is 8, 2 to the 4 is 16, right? See how we're multiplying by 2? 2 to the 5 is 32. So x would be equal to 5 there. And again, we could just punch that in, or we could punch in 2 to the 5 and make sure that we're right there. So there's kind of a few different ways that we can think about this, okay? And then as I said, this note, so if a base is not specified in logarithmic form, you can assume that it's base 10. Base 10 is a very frequent base in mathematical models, therefore it's called the common log. Okay, it's not always going to be written, just like we don't tend to write the 2 with the index for the square root. So that's just the introduction for today. So what I would encourage you to do is read these pages to just kind of go through all the things that we just talked about, And then you guys can do questions 1 to 17. It's a lot of questions, but a lot of them are quite quick. Like it's not the same level of work or whatever that rationals was. So yeah. If you have any questions, let me know. And since you guys are all doing this on different days, you're gonna have to come see me about how do I put this in my calculator, because it might slip my mind because you guys are just doing them all on different days. So help me to help you. Come see me about that. Okay? Awesome.